up with our motto, let learning be a joy and teaching a pleasure. Here we are with a remote teaching and learning process to bridge the gap. Happy learning, students.
Welcome back, students. We'll be doing today Mathematics 2 Standard 10. Topic which we'll be doing is Similarity. We'll continue with this chapter, and the part which we'll be doing today is Practice Set 1.2. Before we start with problem Practice Set 1.2, let us revise what we have done before. Angle bisector property. The statement you can see on the screen: the bisector of an angle of a triangle divides the side opposite to the angle in the ratio of remaining two sides. So in triangle ABC, CE is the bisector of angle ACB, which divides side AB in the ratio of remaining two sides, that is AE upon EB is equals to CA upon CB. This is our two proof which we have already done. We also did last time property of three parallel lines and their transversal. You can see the statement on the screen. The ratio of intercepts made on a transversal by the three parallel lines is equals to the ratio of corresponding intercepts made on any other transversal by same three parallel lines. Line L, line M, line N are parallel to each other. T1 and T2 are the two transversal which intersects these lines at point A, B, C and P, Q, R respectively. We need to prove the ratio of their intercept, that is AB upon BC, made on transversal T1 is equals to PQ upon QR, ratio of intercepts made on transversal T2. We have already proved this. We'll be using this in practice set 1.2 and also basic proportionality theorem and its converse we'll be using in solving practice set 1.2. We have practice set 1.2. Given below are some triangles and the length of line segments. Identify in which figures say ray PM is the bisector of angle QPR. There are three sums in this question. We'll be solving the first one. The first diagram you can see on the screen. In this it is given the length of PQ 7, PR is 3, QM is 3.5 and RM is 1.5. To solve this question, we need to first think what we are going to use in this chapter. I have already said we have done three theorems before this: basic proportionality theorem, angle bisector property and property of intercepts made on three parallel lines. Any one will be using here to solve this sum, to prove PM as a bisector. So can you tell me what will be using here? Yes, you are right. We'll be using property of an angle bisector of a triangle, as we need to prove bisector. Ray PM as a bisector, will be using angle bisector property. Now let us solve this sum. We need to prove PM as a bisector of angle QPR. To prove this, I will divide this screen into two parts. One part is statement. All the statements will be writing in this part on the left side, and to the right side will be writing reason for the statement which we write. Let us begin. To use angle bisector property, actually we are using converse of angle bisector property. To use that, we need to find the ratio of two sides, PQ upon PR. So let us first find out ratio of PQ upon PR, which is 7 upon 3. We know the length of PQ is 7 and PR is 3. This is given, so reason will be given. We'll find out QM upon MR. QM upon MR, QM is 3.5, MR is 1.5. We'll multiply both of them by 10. So ratio will be 35 upon 15, which is again 7 upon 3. Reason will be writing given. Now see why we have found these two ratios. Because angle bisector property says that the ray which bisects the angle divides the side opposite to the angle in the ratio of remaining two sides. So the remaining two sides are PQ and PR, whose ratio we have got, and QM upon MR, that also we have got. If they are equal, then PM will bisect by converse of angle bisector property. So since you can see from equation 1 and 2, PQ upon PR is equals to QM upon MR, reason will be writing from 1 and 2. Therefore, from this we get ray PM bisects angle QPR, and reason will be writing for this is converse of angle bisector property. Let's solve the next one. Sum number 1, part 2. You can see the diagram on the screen. Here the length of PR is 7, PQ is 10, length of RM is given as 6, length of QM is given as 8. Again we'll be first finding the ratio of PQ upon PR, which is 10 upon 7, because their values are given. We'll write reason as given. And we'll also find out QM upon MR. QM is 8, MR is 6. 8 and 6, they both are divisible by 2, so we'll divide them by 2. We'll get ratio as 4 upon 3. So if you see equation number 1 and equation number 2, they are not equal. Equation number 1 we have got ratio 10 upon 7, and equation number 2 we have got ratio 4 upon 3. Therefore PQ upon PR is not equals to QM upon MR from 1 and 2. So here, since the ratios are not equal, ray PM does not bisect angle QPR. Again reason will remain same, that is angle bisector property. Now we have the third part of question number 1. Here PQ is given as 9, PR is given as 10, the length of QM is 3.6, length of RM is 4. Again we'll be finding the same ratios, that is PQ upon PR and QM upon MR. So PQ upon PR will be 9 upon 10, we cannot further divide this. So it will be ratio will remain as 9 upon 10, that is equation number 1, reason will be writing given. And QM upon MR, 3.6 upon 4, which can be written as 36 upon 10. We have removed decimal point by multiplying numerator as well as denominator by 10, and the ratio we have got will be 9 upon 10. So here if you compare equation 1 and 2, they both are 9 upon 10. So that gives me PQ upon PR is equals to QM upon MR. So from 1 and 2 we have got this. Yes, now we have proved this ratio is equal. So ray PM bisects angle QPR, converse of angle bisector property. Let us solve now sum number 2. You can see on the screen, in triangle PQR, length of PM is 15, length of PQ is 25, length of PR is given to us as 20 and NR is 8. We need to find whether NM is parallel to QR or not, and we need to give reason why they are parallel. Now we need to think, how can we prove NM parallel to QR? Now here we'll be proving these two lines parallel by using one of the theorem which we have done before in this chapter. Yes, you are right. We'll be using converse of basic proportionality theorem. To use converse of basic proportionality theorem, we need to find out two ratios, that is Pn upon Nr and Pm upon Mq. So let us first find out these ratios. Now let us solve this sum. You can see the diagram on the screen. Again, since it is proved, we have divided this into two parts, statement and reasons. As I said, we need to find the ratio of Pn upon Nr and Pm upon Mq. We need to find the length of Pn. How we are going to find the length of Pn? We know PR is equals to Pn plus Nr. Reason for this is P dash N dash R. Since these 3 points are collinear and N lies between P and R. We know the length of PR as 20, Pn we don't know, 8 is the length of Nr. So the length of Pn we have got 12 units. We also need to find the length of Mq, which is not known to us. So we'll first find out Mq. We know PQ is equals to Pm plus Mq. Again, reason will be P dash M dash Q, which will give me the length of Mq as 10. Now we'll be finding the ratios which we need to find, that is Pn upon Nr. We have got Pn upon Nr as 3 upon 2. We'll find out Pm upon Mq, which is again 3 upon 2. That proves from 1 and 2 that Pn upon Nr is equals to Pm upon Mq. And you already know why we have proved these ratios equal. If they are equal, Nm will be parallel to Rq by converse of basic proportionality theorem. Let us see sum number 4. Measure of some angles in the figure are given. Prove that AP upon PB is equals to AQ upon QC. Now here we have to prove ratios equal, that is AP upon PB and AQ upon QC. Now we need to again think, how can we prove those ratios equal? Yes, we'll be using basic proportionality theorem to prove these ratios equal. And to use basic proportionality theorem in triangle ABC, we need PQ parallel to BC. We need to prove PQ parallel to BC. Now we need to think, how can we prove two lines parallel? We have done some test of parallel lines in standard 9th. We'll be using one of the tests here to prove these two lines parallel. Since angle APQ and angle ABC, measure of these two angles are given, which are each one of them is 60 degree, and if you see, they are corresponding angles. So we'll be using converse of corresponding angle test to prove PQ parallel to BC. Now let us prove this sum. You can see the diagram on the screen. Again, we have two parts of it: statement and reasons. Statements and reason. Left hand side will be writing statement, right hand side will be writing its reason. So we already know measure of angle APQ, which is 60 degree. Reason is given. Measure of angle ABC, which is again 60 degree, given to us. Since measure of these two angles are equal from 1 and 2, we'll get these two angles are congruent. Therefore PQ is parallel to BC. Reason for this will be converse of corresponding angle test. Since these two lines are parallel in triangle ABC, AP upon PB will be equals to AQ upon QC. Reason will be basic proportionality theorem. Now let us solve sum number 5. You can see the question on your screen. In trapezium ABCD, AB is parallel to PQ, which is parallel to DC. Length of AP is given, length of PD is given to us as 12, QC is 14. We need to find the length of BQ. Yes, since three lines are given to us as parallel, we'll be using property of intercepts made on three parallel lines to prove this, to solve this. So you can see the solution of the same. We have AB parallel to BC parallel to DC. Reason will be writing as given. AP upon PD is equals to BQ upon QC. Reason for this will be property of three parallel lines and their transversal. Will substitute the values which are known to us. We know AP 15, PD is 12, BQ we have to find, QC is 14. We'll solve this. We'll get the length of BQ as 17.5, and that is what we need to find. Now let us solve sum number 10, which is based on activity based questions. You can see the sum on the screen. In the figure, X is any point in the interior of triangle. Point X is joined to the vertices of a triangle. PQ is parallel to DE, QR is parallel to EF. We need to fill in the blanks to prove PR parallel to DF. So in this proof, they have started with first triangle, that is triangle XDE. You can see the triangle in the diagram where PQ is parallel to DE. What reason we are going to write for this? Yes, right. Reason will be given. If PQ is parallel to D in triangle XDE, what we know then? The ratios XP upon PD and XQ upon QE are equal. So in the boxes, XP upon PD will be there and XQ upon QE. Reason for this is basic proportionality theorem, because PQ is parallel to DE, so it divides side XT and XE in the same ratio. Same way in triangle XEF, we have QR parallel to EF. Reason will be given. Now you can see four boxes. they are in the form of ratios, which ratios will be equal if in triangle XEFQR is parallel to EF. Yes, XQ upon QE is equals to XR upon RF, and reason for this will be basic proportionality theorem. So if we compare equation number 1 and equation number 2, we'll get XP upon PD, the left hand side of first equation, is equals to XR upon RF. Yes, we are using transitivity property. 1 ratio equals to 2, 2 equals to 3, therefore 1 is equals to 3. So from 1 and 2 we have got this. If these ratios are equal in triangle XDF, then PR will be parallel to DF by converse of basic proportionality theorem. Let's solve sum number 11. In triangle ABC, ray BD bisects angle ABC and ray CE bisects angle ACB. If segment AB is congruent to segment AC, then we need to prove ED parallel to BC. Now we need to think when ED will be parallel to BC. See the triangle ABC and see in that when ED will be parallel to BC. Yes, you are right, we'll be using converse of basic proportionality theorem. For that we need to prove AE upon EB equals to AD upon DC. Let us find out how we'll prove these two ratios equal. We'll be using property of transitivity. That means we'll prove AE upon EB equals to some ratio. Let us take that ratio as x upon y, and AD upon DC also equals to x upon y. So from these two I'll get AE upon EB is equals to AD upon DC. Now I know how I am going to prove these ratios equal. Let us solve this sum. Let us prove this. You can see the diagram on the screen. Again we have divided this into two parts. Left hand side will be writing statements and reasons for the same on the right hand side. Now we know in triangle ABC it is given that AB and AC are congruent, so reason will be given. Now in triangle ABC it is also given that C bisects angle ACB. So in triangle ACB, if C bisects angle ACB, that is given, therefore AE upon EB will be equals to AC upon BC. Reason for this will be right angle bisector property. Now since AC and AB are congruent, I can write AE upon EB is equals to AB upon BC. I have written AC up in the first ratio as yellow color. In second also AB is written in yellow color. Since they are equal, I have replaced AC by AB. Reason for this will be from equation number 1. We'll number this equation as 2. Now in triangle ABC, it is also given that BD bisects angle ABC. If BD bisects angle ABC, reason for that is given. Then we know AB upon BC is equals to AD upon DC. Will be our equation number 3. Reason for this is also angle bisector property. So if you compare equation 2 and 3, here we get the transitivity. Ratio 1, that is AE upon EB, is equals to AB upon BC. And in equation number 3, AB upon BC is equals to AD upon DC. So we'll get from 2 and 3, AE upon EB is equals to AD upon DC. If these ratios are equal, DE will be parallel to BC. Reason will be converse of basic proportionality theorem, and that is what we need to prove. If you remember, there are few sums which we have left in between. Those sums you will be solving as homework. You can see the first two sums on your screen. Sum number 6 and 7, which will be solving as homework. In sum number 6, you will be using angle bisector property. And in sum number 7, you will be using property of intercepts made on 3 parallel lines. These two sums also we have left in between, which we'll be doing as homework. Sum number 8 and sum number 9, both will be using angle bisector property. Sum number 9, the values are given in x form. So you need to solve this by using quadratic equation. When you solve this, you'll come to know how to complete it. If you have any doubt, we'll be discussing in the next class.